Imagine stepping outside on a clear night. The air is crisp and the world is quiet. You take a deep breath and look up. You look up, but something is different. The night sky, usually dotted with familiar stars, now holds a surprise. The familiar points of light that dot the night sky are transformed. Each planet now shimmers with an ethereal glow, casting a soft, otherworldly light. They are adorned with rings, celestial necklaces of ice and dust. These rings catch the light, creating a mesmerizing display. Our solar system has become a dazzling display of cosmic grandeur. The planets, once solitary wanderers, now wear their rings like crowns, transforming the night sky into a celestial masterpiece. From the faint, ethereal rings of Mercury to the massive, complex structures encircling Jupiter, each planet boasts its own unique halo. These rings tell a story of their own, each one a testament to the forces of nature. Venus, our sister planet, is draped in a delicate, shimmering veil. Its rings are like a gossamer curtain, adding to its allure. Mars, once a solitary red dot, now flaunts a vibrant, rust-colored ring system. These rings give Mars a new identity, a new story to tell. This awe-inspiring sight sparks our curiosity. We are filled with wonder, our minds racing with questions. We are drawn to the heavens, eager to understand the forces that could create such breathtaking beauty. What events led to the formation of these rings? What secrets do they hold? The universe has always held mysteries, but now, with a ringed solar system, it seems even more vast, more wondrous, and full of untold stories. Each ring, each planet, is a chapter in the grand cosmic narrative, waiting to be explored and understood. The visual impact is profound. Rings reflecting sunlight create dynamic patterns, and the shadows they cast add depth and dimension to the planets. This new celestial artwork invites us to see our solar system in a whole new light. Imagine the time-lapse of these ringed planets moving across the sky, their rings creating halos that dance with the celestial light. This visual symphony would be a constant reminder of the beauty and complexity of our universe. The intricate details of the rings, composed of countless ice particles and dust, would reveal dynamic structures that change with the planet's movement. Each ring system would be a living, evolving masterpiece. The rings would cast colorful shadows, creating prismatic effects that add vibrancy to the night sky. This interplay of light and shadow would make our solar system a breathtaking spectacle, a true wonder of the cosmos. From Earth, the most dramatic change is the appearance of our own rings. Imagine a shimmering band of light arcing across the sky. It would be visible day and night, casting faint shadows and transforming our perception of day and night. During the day, the rings would appear as a luminous arch, a ghostly rainbow against the blue sky. Sunlight, scattered by ice and dust particles, would create a breathtaking spectacle. At night, the rings would reflect city lights, creating a surreal glow in the sky. However, this celestial beauty comes with a price. The rings, while visually stunning, would disrupt Earth's climate. The shadows cast by the rings would cause temperature fluctuations, leading to unpredictable weather patterns. Regions once bathed in sunlight might experience prolonged periods of twilight or even darkness. Agriculture would suffer as crops struggle to adapt to the altered light conditions. Wildlife would be confused by the changing light patterns, disrupting natural behaviors and ecosystems. Human activities would also be impacted as societies adjust to new day-night cycles and unpredictable weather. Scientists would need to study the ring's impact extensively to understand and mitigate these disruptions. Global efforts would be required to adapt to these changes, fostering international cooperation on climate issues. Coastal areas might experience rising sea levels and increased flooding due to the climate changes induced by the rings. The polar ice caps could melt at an accelerated rate, contributing to global sea level rise. The frequency and intensity of storms and extreme weather events could increase, posing new challenges for disaster management. Human health could be affected as people cope with new environmental conditions, including heat waves and altered air quality. Technological advancements would be crucial in mitigating these impacts, driving innovative solutions for climate adaptation. Communities would need to work together, building resilience in the face of these unprecedented changes. The ring's impact on Earth's climate would be profound and multifaceted. Imagine the rings casting broad shadows across the planet's surface, creating vast areas of reduced sunlight. These shadows could cool certain regions significantly, potentially disrupting agricultural cycles by altering growing seasons and affecting crop yields. Furthermore, the rings would reflect and scatter sunlight, creating a dazzling display in the sky, but also diffusing light in unpredictable ways. This scattering effect would change the amount and quality of solar radiation reaching Earth's surface, leading to variations in temperature and weather patterns. The delicate balance of our planet's ecosystem would be thrown into disarray, affecting plant photosynthesis and animal behaviors. These changes would necessitate global cooperation on an unprecedented scale to address the new challenges. We would need to adapt our agricultural practices, such as developing crops that can thrive in lower light conditions and create new energy solutions to compensate for the altered climate. Scientists would study the new light patterns extensively, creating simulations to predict how these changes would affect our daily lives and long-term climate. Urban planning and architecture would also need to adapt, designing buildings and cities to cope with the altered light conditions, such as maximizing natural light and minimizing shadow impacts. International climate research teams would work tirelessly to model and understand the long-term effects of the rings on global weather systems, ensuring we can adapt to this new reality. The presence of rings around other planets would pose significant challenges for space exploration and communication. Satellites and spacecraft would need to navigate through these celestial minefields, increasing the risk of collisions. GPS signals, reliant on a clear line of sight to satellites, would be frequently disrupted. This would impact navigation, communication, and even financial transactions that rely on precise timekeeping from GPS satellites. We would need to develop new technologies and strategies to overcome these challenges. Spacecraft would require advanced shielding and maneuverability to avoid ring particles. New communication systems, less susceptible to interference, would need to be invented. Engineers would need to test new materials and designs to ensure spacecraft can withstand constant bombardment from ring particles. Advanced AI systems would be crucial for real-time navigation and collision avoidance. Quantum communication technology might offer a solution, providing more reliable data transmission through the interference. A global network of ground stations would be essential to maintain communication and monitor satellite health. Planning space missions would become more complex, requiring detailed analysis of ring dynamics and particle distribution. Spacecraft would need to perform complex maneuvers to navigate safely through the rings, adding to mission costs and risks. Advanced propulsion systems would be necessary to provide the agility required for navigating through dense ring systems. Detailed analysis of ring particle composition and behavior would be essential to predict and mitigate potential hazards. Space stations and habitats would need enhanced shielding to protect against the constant threat of ring particle impacts. Autonomous repair systems would be crucial for maintaining spacecraft integrity in the harsh environment of planetary rings. Innovative solutions like magnetic shielding could be explored to deflect ring particles and reduce collision risks. International collaboration would be key to developing the technologies and strategies needed to safely explore and utilize planets with rings. Despite the challenges, a ringed solar system would be a source of endless fascination. The rings would be dynamic and ever-changing, constantly influenced by gravitational forces and cosmic events. Collisions between ring particles would create dazzling displays of light and color, adding a new layer of complexity to our understanding of planetary systems. The night sky would become a celestial ballet, with each planet's rings performing their own unique dance, influenced by the gravitational pull of nearby moons and planets. Observing these changes would provide scientists with valuable insights into the forces that shape our solar system, from tidal forces to the impact of meteoroids. Imagine witnessing a meteor shower, not just on Earth, but also on Saturn or Jupiter, where the rings would interact with the meteors, creating spectacular visual phenomena. These events, magnified by the presence of rings, would be truly awe-inspiring, showcasing the dynamic and ever-changing nature of our solar system. The gravitational interactions between planets and their rings would lead to constant shifts and changes, making our solar system a living, breathing entity. Over time, these rings would evolve, forming new patterns and structures influenced by the ever-changing cosmic events and forces at play. Each planet's rings would possess unique characteristics, reflecting their individual histories and compositions. Jupiter, the giant of our solar system, would be encircled by a massive and complex ring system. These rings would be composed primarily of dust and small rocky particles, creating a shimmering halo around the gas giant. The intricate structure of Jupiter's rings would reveal the dynamic interactions between its moons and the planet's magnetic field. Saturn, already renowned for its majestic rings, would become even more breathtaking. Its rings, made mostly of ice particles with some rocky debris, would span hundreds of thousands of kilometers. The Cassini division, a dark gap within the rings, would be more pronounced, showcasing the gravitational influences of Saturn's moons. The rings, now even brighter and more intricate, would be visible even to the naked eye, casting a delicate glow in our night sky. The Encke gap, another division within the rings, would be a striking feature, highlighting the complex gravitational interactions at play. Uranus and Neptune, the ice giants, would also boast spectacular ring systems. Uranus's rings would be dark and narrow, composed mainly of large icy chunks and some dust. These rings would be tilted dramatically due to Uranus's unique axial tilt, creating a fascinating visual effect. Neptune's rings, though fainter, would be made of dark organic materials and ice, creating a mysterious and captivating sight. The rings would be segmented into distinct arcs, a phenomenon not seen in other planetary rings, adding a unique charm to the distant planet. Despite their subtlety, these rings would provide valuable insights into the composition and history of Neptune's environment. Have you ever wondered how the mesmerizing rings around planets come to be? This enigma has captivated the minds of astronomers and scientists for centuries, sparking countless studies and theories. The birth of planetary rings is a tale of cosmic forces in perfect harmony. Gravity and tidal forces engage in a celestial ballet, sculpting the magnificent structures we marvel at in the night sky. Imagine a moon or a comet wandering too close to a planet. The planet's immense gravitational pull can tear it apart in a dramatic display of raw power. This celestial disintegration is a testament to the formidable forces at play. This critical boundary is known as the Roche Limit. Within this limit, tidal forces overpower the gravitational cohesion of the celestial body, leading to its spectacular breakup. The shattered fragments then settle into orbit around the planet, coalescing into a ring system. These rings are a mosaic of countless particles, from minuscule dust grains to sizable chunks of rock and ice. Over time, these particles collide and interact, evolving the ring system. The composition of these rings offers clues about the original celestial body, providing a window into the solar system's turbulent history. Studying these rings is like unlocking a cosmic time capsule. Each ring system holds invaluable insights into the formation and evolution of our solar system, preserving the secrets of the events that shaped it. By delving into the composition and structure of the rings, scientists can piece together the narrative of planetary formation and the cosmic events that sculpted our corner of the universe. This research not only enriches our understanding of the past, but also helps us foresee future changes in our solar system. The ever-evolving rings continue to unveil the dynamic processes at work in our universe. Some scientists believe that Earth may have had its own ring system in the distant past. This intriguing idea suggests that our planet, much like Saturn today, could have been encircled by a magnificent ring of debris. Evidence for this theory can be found in the geological record, which hints at a period of intense bombardment by asteroids and comets. These celestial bodies bombarded the early Earth, leaving behind craters and layers of debris that we can still observe today. It is possible that one of these impacts was large enough to create a ring system around our planet. Imagine a colossal asteroid striking Earth with such force that it sent debris into orbit, forming a temporary ring. Over time, these rings would have coalesced to form our moon, leaving behind only faint traces in the geological record. The process of ring material gradually coming together to create the moon is a fascinating aspect of our planet's history. If Earth did indeed possess rings in the past, it would have had a profound impact on the evolution of life. The presence of rings could have influenced the development of ecosystems and the way life adapted to the environment. The rings would have affected Earth's climate, tides, and even the length of a day. The gravitational pull from the rings could have caused significant changes in tidal patterns and climate, potentially altering the course of evolution. Understanding this ancient ring system could hold the key to unraveling some of the mysteries of our planet's early history. By studying the geological records and piecing together clues, scientists hope to gain a deeper understanding of how these rings shaped the Earth we know today. Advanced technology and computer simulations are now being used to recreate these ancient conditions. By modeling the impact of rings on Earth's environment, scientists can explore how these celestial features might have influenced everything from climate to the development of life. Analyzing ancient rock samples and data allows researchers to piece together the puzzle of Earth's ringed past. Each discovery brings us closer to understanding the profound implications these rings had on our planet's history and evolution. As we continue to investigate Earth's potential ringed past, the findings could revolutionize our understanding of planetary formation and the dynamic processes that have shaped our world. The quest to uncover these ancient mysteries is just beginning, and the implications are truly awe-inspiring. The geological record provides a treasure trove of information, revealing the cataclysmic events that may have led to the formation of rings. By examining the layers of rock and sediment, scientists can identify the specific periods of intense bombardment and the subsequent changes in Earth's environment. Computer simulations allow researchers to recreate the conditions of early Earth, providing insights into how a ring system could have influenced everything from atmospheric composition to ocean currents. These models help us understand the potential climatic and ecological impacts of a ringed Earth. By analyzing isotopic compositions and mineral structures in ancient rock samples, scientists can trace the origins of the debris that may have formed Earth's rings. This data helps build a timeline of events, shedding light on the processes that shaped our planet's early history. The ongoing research into Earth's potential, ringed past, is a testament to human curiosity and the desire to understand our place in the cosmos. Each new discovery brings us closer to unraveling the mysteries of our planet's formation and the dynamic forces that have shaped its evolution.